So we are working through order of operations today. So we're going to evaluate exponential expressions, evaluate square and higher roots, evaluate expressions using the order of operations. So before we jump into our notes for the day, you have a practice quiz that I wanted you to work on. Okay, that is right here. So if you've done that already, continue the video. If you haven't done that yet, pause the video and work through the practice quiz questions, and I will give you the answers when you're done. So we need to get these to be the same common denominator of 20. All right, so change this to a 20. We're going to multiply it by 4. Okay, which means we also have to multiply this by 4. So that fraction is 12 over 20. Multiply this one by 5 to get a 20 down there. All right, so this would be a 20. Take this times 5, that would be a 15. Take this one times 10. Take this times 10. Okay, and now we have our three new fractions. So 12 over 20, 15 over 20, 10 over 20. So 12 plus 15 is 27 minus 10. We have 17 over 20 for that one. If you use the calculator, which is fine, I prefer you use your head. Okay, so if I use the calculator, 17 over 20 is about 0.85. Okay, so when you're working on the ACT, if you get a question like this, you're going to have an answer like this rather than that. So you could learn how to convert these back into that, but it might be more efficient just to get a common denominator. Okay, so second one, we know that we have a double negative there, so double negative, we can kind of change those to a positive. We get a 20 for that one. All right. So down here, we're working with absolute values. So absolute value changes everything to positive. And we are doing division with two fractions here. So remember, when we're dividing two fractions, you skip, flip, multiply. So we're going to flip the second one to a 2 over 1 and multiply. So we're going to multiply straight across, which I think is the way you learned in middle school. You can cross cancel, but we'll take care of that here. So 7 times 2 is 14 over 6. And then we simplify that down. We take a 2 out of the top and the bottom, which we get 7/3. For the next one, we're looking at this one. So we look at the two groups. The parentheses are here on the left and here on the right. So this is associative property. We are associating those parentheses, or we're associating different groups. So this is associative of multiplication. For this one, we're adding an opposite. So this is just the additive inverse. Okay, and you can reference those properties in your notes from the previous lessons. So for number 6, we have this set for A, this set for B. We want to find an intersection. Remember, that is an N, looks kind of like an N for intersection. And we want to write the same thing from both sets. So we have a 1 in both of them, we have a 5 in both of them, and we have a 9 in both of them. We put them in curly brackets. Union, that's the U shape. That's one of everything. So 1, 2, 3, 4, 5, 7, 8, 9, and 11. And we put all these in curly brackets because we're noting a set. Okay. Then for number 7, we have this set. We want to list these from each thing. So this is a natural set. This is a whole set. This is integers. Q stands for rationals. So rational number. So H is irrationals. And then we just want to list each of these numbers in their corresponding set. So for naturals, we're going to have, remember, those are just counting numbers. The only one in there is 44. And then for whole numbers, it's like natural numbers, but it has a whole in it, which is the 0. So we have 0 and 44. Okay, integers are just whole numbers that are positive and negative, so no decimals. So we have a -5, a 0, and a 44. And then for rationals, rationals is anything that can be written as a fraction, which would be pretty much every number here except for the square root of 11. Square root of 11 is a bad decimal, which is hard to approximate unless you have a calculator. That goes in irrationals, and then all the other ones are rationals. So -5, 0, 3/4, 12.25, and 44. Okay, and then number 8, write this as a fraction. So remember, we need to figure out how many decimal places are repeating. This is 2. We're repeating to the 100th place. Okay, for every repeating decimal place, we're going to multiply this by 10 when we're solving this out. So we write out the original, x equals 3.45 repeating, and then we write out the next one, which is 2 decimal places, so we're going to multiply this by 100. So 100x, and multiplying this by 100 moves the decimal place twice, 345.45, that's our repeating slot. Okay, now we subtract these two. That's how we get to our repeating decimal. So we have 99x on the left, and over here when we subtract these, that 0.45 is going to cancel out, and we'll have 342. Okay, and now we're pretty much to a one-step equation where we have to solve this. So we divide both sides by 99. So 342 divided by 99 is our fraction. And we want to make sure that we reduce this down. So if we reduce this down, taking out a 3, we get a 114 over 33, and we take out a 3 again, and we get a (38 over 11), and that's as far as we can go. Okay, so that is your practice quiz. Hopefully you kind of got most of those right. If you didn't, you might want to go back and replay the video that's in Canvas for you. Okay, so on to the lesson. So looking at evaluating order of operations. The first thing you start with is parentheses. We're going to get to that in a minute, but we've got to be able to evaluate exponents. So if you have an exponent like that, that's just 3 squared, which is 3 times 3. We should know that. 3 cubed, that's 3 written out 3 times. We should also know that. And then we can generalize it to an nth power, where you just write out how many times, like you could do the 23rd power if you want to. In a calculator, it might be an x squared button. There might be a button like this. That's how you do an exponent there. Most of them are going to have this little caret like that. So this would be 6 to the 4th power. That's the way most of them are going to work. All right. So let's check it out down here. So 5 to the 3rd, that's just 5 times 5 times 5, which evaluates to 125. Okay. Now this one here, you got to be a little careful with, because it's got a negative inside of an exponent, okay, or a negative inside with a number for the exponent. So this is going to take that negative 4 times as well. So this would really be like this, -3, -3, -3, -3, 4 times. Okay, so those 4 negatives are going to cancel out and make this a positive. So this would be 3, 9, 27, 81. So this would evaluate to 81. Okay, which we're going to check that out again here and here. So this one, 6 to the 0, is just a 1. So that's a special number, a special exponent. If any exponent is a 0, that's going to turn the number into a 1. And I can show you a proof for that if you'd like that later. So this one technically should have parentheses around there. So 4/7, we're going to write that out 3 times. Oops. And then it works the same as these. Okay, so 4 times 4 times 4, that's a 64 in the numerator. 7 times 7 times 7, that's a 343 in the denominator. Okay, so that's how we do an exponent with a fraction, parentheses, regular number. Okay, so let's put this in a problem here like this. Let's evaluate this one. So -5 squared. So remember, the parentheses are what make me write that negative out multiple times. If there are no parentheses, I'm not writing the negative out. So this would really be a 25 here, and then the negative goes back to it. So this is a negative 25 for the first number. All right, so this one gets the negative twice because we have parentheses around that, so that should be written like this. So that would be a positive 25. Okay, and then same idea here, no parentheses. We don't have to write the negative out 3 times, but it shouldn't matter since it's a cube. So minus 64. This one writes the parentheses out 3 times. Okay, but like I just said, it's a cube, so cubes are always going to have whatever that sign is. They're always going to maintain that. If it's a negative, it'll be a negative. If it's a positive, it'll be a positive. So that's going to be plus another negative 64. And then we just go from left to right. So that and that are going to give me a 0. Negative 64 plus negative 64 is negative 128. Okay, so that is order of operations when we're working with exponents. So when we're working with radicals, which works similar to exponents, you ask yourself, what number times itself twice gets me to a 16? In this case, negative 4 and 4 both get me to a 16. However, in general, you usually just take the absolute value of that and you're going to take the positive. Okay? Now this is just a square root. We could work with higher roots like a cube root, fourth root, fifth root, etc. And that's going to be shown in by that little number there, which is called the index. Okay? So again, what number times itself n times will give me the number underneath the square root? That's the question you ask yourself to evaluate these. Okay? So starting out basic square roots, then we're going to do basic cube roots. These are ones that you should commit to memory. It makes you a lot more efficient mathematically if you memorize these. So we're just going to fill these out real quick. What times itself twice gets me a 4? That's a 2. What times itself twice gets me a 3? Or a 9, excuse me. That is a 3. And then you can kind of see a pattern here. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And we're just going to keep filling this out so we have it. Okay. Cube roots work a little bit different. This is what number times itself 3 times, because the index is 3, gives me an 8. So that is a 2. Because 2 times 2 times 2 is 8. What number times itself 3 times is 27. That should be a 3. And then you can kind of guess, again, the pattern is 4, 5, and 6. So 6 times 6 times 6 is 216. Okay? Those are perfect square roots and cube roots we'll be working with. For the most part, these are the ones we're going to be sticking with. Sometimes we'll get to 12 times 12, so this would be maybe 11 times 11 is a 121. Okay, and then the 144, those are numbers we've seen before. Okay, and I lost my question here. Let's just say that this is going to be a basic square root like that. Okay. And this is just what number times itself twice is 25. That would be a 5. And then for fractions, you got to think about it like this. We split them up. Okay, where you cube root the top, cube root the bottom. And then that should make it a little bit easier. So cube root of 1, that's just a 1. Cube root of 8, that's a 2. And then that would be your answer. Okay. Same way here, square root the top, square root the bottom, we'd have 5 over 6. And you should be able to reduce these, or sometimes you can reduce these, make sure you reduce them all the way. Cube root 64, that's one we wrote down, that's a 4. Fourth root 16, we didn't write down fourth roots, but we should be able to kind of think through it. What number times itself 4 times gets me a 16? Generally, you start with the smallest number you're multiplying by itself. You start with 2's, and then you go up from there. In this case, this is 2, 4, 8, 16. We got it. So 4th root of 16 is just a 2. Okay? But that's the process. What number times itself, n times, in this case 4, will get me the number underneath the radical. All right? So getting to the good stuff here, and we'll try a couple of these, and we'll be done. So basic order of operations. We've learned this in every single one of our math or our algebra classes up to this point. So parentheses, exponents, multiplication or division, addition and subtraction. This also includes radicals here. Radicals fall under the exponent category. Radicals are actually exponents. Just disregard this stuff over here. We're just going to try to practice some of these examples on the next slide. Okay, 2 examples here, then we'll be done. I'll show you how we should do these. You can do a long way or a short way. However, you should show at least 2 or 3 steps on these so I know that you're doing it correctly, or so we can find some mistakes if we have them. Okay. So for 11, we start here, and parentheses the first thing we look for. So we go all the way on the inside here, and we're doing 4 minus 1 first. So 4 minus 1 is a 3. And then just for the sake of this question, I am going to rewrite it out so you can see every step. Okay, so now we reevaluate this. Next step for the parentheses would be these brackets. So 5 times 3 is 15. And then I'm going to rewrite it again. 7 minus 15. And I don't really need the brackets here again, but I'm just going to write them out. Okay, so now we're inside here. We're doing 7 minus 15. So that's a negative 8. So we have this now. Okay, so from here, we got to use that exponent. Okay, so we got 9 plus 64. And it should be a positive 64 because we're applying the exponent with the negative as well. And we finish this out. 9 plus 64 is 73. Okay, so I wouldn't have to show every single one of these steps, but I want to see that you can do a couple of those. So show a couple steps for larger order of operation questions like this. Okay, let's do one more of these. So I want you guys to try this one on your own, and then we'll go through the answer. So pause the video for a minute here, and then come back for the answer. All right. So first step you want to do is parentheses, and absolute values kind of go with parentheses as well. So 9 minus 10, that'd be a negative 1, which is just a 1 because it's in parentheses. Or it's in absolute values, excuse me. So 3 minus 9, this is just regular parentheses, that's a negative 6. And I'll rewrite these out. Okay, that's my numerator. And then on the denominator, 3 minus 6 divided by 2. Next step we got to take care of would be multiplication and division. So 12 divided by a third, if I put that in my calculator, I should get 36. All right, this would be the same thing as timesing by 3. And I got 7 times 1, which is just a 7. So my numerator again would be 36 plus 7. Denominator 3, well, we got to do this first. So 6 divided by 2 is a 3. So we got 3 minus 3, which is just a 0 on the bottom. So to finish this out, 36 plus 7, 43 over 0. And you run into this stuff. If you put that in your calculator, you're going to run into some problems. All right. So if I do 43 divided by 0, that might give me a divide by 0 error because we can never divide by 0. Okay, so this is undefined. Yes, we did a little bit of extra work for an undefined, but that's okay. We did it right if we get that. Okay? So to finish out here, we have a Kahoot we're going to try to see if we remember number sets, and then we have a GIMKit that we're going to try to set up order of operations. So I'll put these in Canvas, and the sub is going to try to get these set up for you, see if they work. If they don't, help her out a little bit, and we'll get it going. All right? So if you have any questions, let me know. Thanks for watching.